Frequently in civil engineering, we use symbolic diagrams to indicate complicated processes. An example of that could be a treatment plant, could be the storm sewer, sanitary sewer, water line. Many systems are very complicated, and we are unable to indicate all of the processes on a typical plan sheet. Now, that doesn't mean that we don't use the plan sheet. We still supplement the plan sheet with a simplified diagram. There is just too much information on your typical plan sheet to be able to indicate all of the information that you need to. Specifically for a large construction project, it's where multiple sheets are involved. There's no one clean way to identify all the information, and so we do that with flow and process diagrams. Now, flow and process diagrams are going to get us into a little bit of symbology. Some of the conventional symbols we use. Not only is this important from a graphics point of view, but as engineers, you need to learn how to read prints. Whether it's your prints, when I say prints, plan set, whether it's yours or someone else's, you need to be able to identify what's going on in a civil engineering project. So the first one we're going to look at is a flow diagram. There's a couple symbols here that we need to discuss. First of all, back to our original kind of comments on title blocks. We have the sheet title, we have the sheet number, we have the status of the project. We also have the identifying information as far as who the project was engineered by, and some more information. So there are some symbols and lines here, and we need to identify what those are. The way that we do that is in a legend, and on some of your projects you will need this. It tells the reader what the symbols mean on the plan set. So this is a legend, and it's just representative of certain items on this particular sheet. Now, this legend needs to appear on every sheet that there are symbols that need to be defined. So one legend is not really appropriate for multiple sheets. Okay, so let's kind of go through this. This is a flow diagram, and the word flow diagram just indicates, hey, there's water flowing. We're going to describe how it flows. So go through a couple of different symbols here. This here, and I'm going to zoom in a little bit. That is a symbol for a valve. Now there's, and we're going to learn additional valve symbols, but anytime you see a necking down, so in other words, what the symbol is saying is the flow is being reduced or changed and pinched off, if you will. And the double triangles pointed together is an indication of some type of valve. Now there's of course, other valves, but and there's other symbols, but anytime you see double triangles, it's definitely a valve. Another thing that this flow diagram does is have corresponding lines and arrows that indicate the path of flow. If it's two-way flow, then you would have an arrow pointed each way, but by, for instance, this line here, which is here, here, and here, all the arrows are pointed one way, so that means that there's only possibility of flow one way. Again, you could have flow two ways, but in this case it's not. Now this is not a scaled drawing. This is a symbolic drawing. And there's a big difference between the two, and I want you to understand what this means. This is a simplification of the entire plan set. This plan set, if you look right here, is 109 sheets to it. This simplifies the whole set into one diagram, and it's easy for the reader to understand than to try to go through 109 sheets and figure out what in the world we're trying to do. Okay, we've also done a couple of things on this by existing structures and new structures, and we've played with the color to indicate that. Notice that some of these are dark and some of these are light. That tells the reader which one is new and which one is existing. Okay, we've listed some more information on here as far as lengths, widths, and volumes. It's just a easy thing for the reader to comprehend the size of this particular plant. Just so you know, FDEP requires this type of diagram on pretty much any submission, whether it's a water treatment plant, a sewer treatment plant, or any of the other particular DEP regulated things. Okay, so that's the flow diagram and process diagram. So I want to go to cover another couple of small things. On a floor plan such as this is a structural slab. You have I-beam or wide flange columns. This is all the slab. Notice we've got the dimensions here. We've covered all of this, witness lines, etc. And we have some details here. Now, we're not going to, in this detail, which is here, we are describing a control joint. And the control joint keeps the slab from cracking in places we don't want it to. So the entire width of the slab is not shown in this detail, but we don't want to just end it, and we don't want it to run all the way out of the page. So we put in break lines. This just means continued beyond this area, and there's two sets of break lines here. This line with this squiggly middle, that's just continue beyond. So you will use these a lot as you limit your work. The break line could also be almost a flat S, as this one is. So the same situation. It's just saying work beyond. This is the footer. This is a slab, just a different style altogether. Maybe two S's back to back and flipped. This is another break line, which is here. This is the detail, what we're trying to show, the section. Remember to our discussion of sections and what these particular things mean. As we drew the section, our interest is this particular area here. It's not anything above it. Now we have columns and roof lines and all of that stuff above it. The work continues, but we're not showing that, and we need to break the view here by using this. So we have breaks on this, here. So anything above this line is not shown. That just is a finishing point, if you will. So again, 3 styles of break lines: here, here, and here. You'll use these on pipe networks. When you get to a particular end, you'll break it. Maybe a floor plan, the same way. All types of civil work has break lines on it. Okay, let me find one more application of it. This is concrete ramp, a detail here. It resides on sheet CLB2, detail 1, scale is here, the title is here. All of these aspects have to be included. Now what this detail is showing is a couple of things that are required for the contractor to build this ramp. This could be an ADA ramp, and ADA is basically handicap. You could find that on virtually any civil project. But what we're saying is build a 4-inch thick slab, 4 feet wide. At the end of the 4 feet, we start going up at a 1 to 12. And what does this 1 to 12 mean? That's percentage. So we're saying you go 1 inch up and 12 inches horizontally. Okay, 1 inch vertical, 12 inches horizontally. We're not calculating the thickness here because this is going to be dependent on how far we run, since it's a slope. So we've said as required. That's another way to use dimension lines. You can type words in them. Instead of putting a number there, we said as required. And we have finished it out with a break line. Now the work still goes to the right side of the page, but we haven't. We don't want to show that currently, so we've done a break line. Now, a couple of things about a break line: it should go past the edge of the work. Notice that the bottom of the slab is here. Bottom of the slab is here. Notice the break line goes past it. Same way here. Bottom of the slab, and the break line goes past it. Okay, so all of those items should be, and nothing should extend to the right of this line. Make sure that you don't have anything that hangs over the edge, if you will. We've also done a call out here that indicates where you can find the rest of these details. So the rest of the details are on CLB 1.0, and we can find out what is on the right side of this project.